Good afternoon. Welcome to session 6 of European Entrepreneurship and Innovation Thought Leaders. Today we're going to be presenting two very interesting speakers out of Northern Ireland and Finland. This is our official Invest Northern Ireland Day, and so we'll be presenting our third professor entrepreneur out of the University of Ulster, along with very interesting, I would say, design startup out of Finland. So our two companies today are Intelesens, with Professor James McLaughlin, co-founder and CTO of Intelesens out of Belfast, UK, and then Kai Backman, CEO and founder of TinkerCAD. Brian Glynn of Invest Northern Ireland will proceed with a brief overview of the innovation ecosystem, entrepreneurship ecosystem in Northern Ireland, and a little bit about Invest Northern Ireland itself. We're now going to go to the main program. Brian, we're going to kick off with you with an intro to Northern Ireland and Invest Northern Ireland. So please welcome Brian. And Brian, you're based here in San Jose, right?
Here in San Jose, yeah. Thanks,
okay.
Burton.
Please.
Hey everybody, thank you for the opportunity, Burton, to speak today. I don't have as fancy a title as Mighty Eagle like our speakers from Finland next week, but nonetheless it's great to be here. For those of you who have been to the previous classes, I'm sure you've seen Invest Northern Ireland flashed up on the board in front of us, and it's nice to have the chance today just to tell you all a little bit more about what we do. Professor Jim McLaughlin from University of Ulster will give you a really good insight, I think, into some of the innovative entrepreneurs and research that's going on in Northern Ireland today. But it's nice for us to have the chance to tell you a little bit more about what it is we do ourselves. As Burton said, I'm based here in San Jose. I've been in the Bay Area for the last 3.5, 4 years at this stage. So who is Invest Northern Ireland? We are the economic development agency for the government of Northern Ireland. Our goal, as you see, is to help create wealth for the benefit of the whole community. So we are funded by the government. We're part of the Department of Enterprise, Trade and Investment. We have an office here in San Jose, as well as a team of we're about over 25, I think, across the US now. US headquarters is in Boston. We're also in New York. We're also in New York, Chicago, we have people up in Toronto, and we're all over the world. We do two main ways that we help create this wealth for the community. It's through helping indigenous companies in Northern Ireland who want to grow and scale into overseas markets, as well then as helping companies in those overseas markets in the US here who want to grow and look at expanding into Europe to consider Northern Ireland. As I say, you see some of our locations where we have offices there. We've pretty much on every continent all over the world. Back in Northern Ireland, we're over 600 people. We are kind of the go-to business development body if you're an entrepreneur and are starting up and getting off the ground. It's Invest Northern Ireland that you're talking with. And as you'll see here, our global office network is growing every single year. So for those of you who may not be too familiar with our little part of the world, we're small but dynamic, as we like to say, population of only 1.8 million, but one of the fastest growing and youngest populations in Europe. Just by means of comparison, it's actually pretty similar in size from a population point of view as Santa Clara County, where we are here today. But the area in Northern Ireland, we're about 4 times the geography in area-wise. So how does Invest NI help? How do we help international companies to come into Northern Ireland? And what is it we do for those indigenous companies who want to grow overseas? So there's a whole range of supports that we can offer, both hard and soft, both financial and non-financial. Everything from capital investment to employment ramp up. We help support training costs, research and development, as well as the non-financial supports and actually helping find those people that might seed your team in Northern Ireland or help in a mentoring aspect for new entrepreneurs who want to grow. We also make our clients aware and help connect them with various tax incentives that exist in Northern Ireland, such as pretty generous research and development tax subsidies, as well as a new tax program that's just kicking off now this next financial year called the Patent Box, which means that profits held on patents that you hold in the UK receive a corporate tax rate of just 10%. So that's another innovative approach that we use to help those companies come into Northern Ireland. And here is a selection of those guys that have been availing of those supports and have chosen Northern Ireland as their European destination. Some of the local companies here who I'm sure you'll all recognise. We've the likes of Seagate are in there somewhere amongst the logos. CyberSource, who are a Visa company, HP 3PAR. You'll see a number of financial services companies there, the likes of New York Stock Exchange or Allstate or Citigroup. We've had a lot of success in recent years in that kind of FS tech cluster for a number of reasons, which we'll show you now. So why Northern Ireland? We talk about the 6 C's: close to customer, cost competitive, culturally compatible. From a cost point of view, we find that the clients that we're working with are all pretty thrilled to hear when the operating costs for doing business in Northern Ireland are significantly lower really than anywhere else in Western Europe and the UK. You're talking 20 to 30% cheaper for the most part. We're close to the customer in Europe who our clients are trying to serve, as well as having that little advantage of having an overlap with the working day from a time difference point of view with the West Coast and this part of the world, which seems small but is important when you're trying to get a hold of your team members. And a cultural compatibility, which means that we have some of the lowest labour turnover rates of any European country of under 5%, and the vast majority, as you'll see, of our investors do come back and reinvest with us again. The real trump card, I think, while we have these 6 C's, the real trump card for us is talent. It's a highly educated workforce. Everyone here in the Valley knows about the talent crunch that's there and how difficult it is to hire. And for us to talk about the strength of our talent and our labour pool is really attractive to investors that we speak with. Our students and our academics consistently outperform their colleagues both in the UK and Europe, as you'll see here, and some of these are results from some of the main high school exams. And our universities, the likes of Queen's, which is part of the Russell Group, the UK Russell Group, like the Ivy League, UU, which Professor McLaughlin is proudly representing today, and our regional colleges like Belfast Metropolitan College are all producing world-class talent that's available and highly skilled. So I think there's an interesting history of innovation, which I know Burton and I have often chatted about, and might be interesting as we talk about that kind of legacy of an innovative ecosystem and an entrepreneurial ecosystem. I suppose some of the kind of Mark Zuckerbergs or Steve Jobs of their day were from Northern Ireland back over the last 100 years. Harry Ferguson, modern tractor inventor, John Boyd Dunlop and the pneumatic tyre. There's a really interesting kind of legacy of innovation in Northern Ireland that I think a lot of the time isn't widely known. And Professor McLaughlin will speak a little bit about that legacy, I think, from a connected health point of view and a healthcare point of view, which is something that we're always keen that the wider public knows out there and isn't always necessarily widely known. Today, that kind of innovation continues with some of our investors like Seagate. I see in lots of laptops staring back at me here, and we've all probably owned 5 or more. If you have, then the chances are you've owned a PC that has parts of its hard drive made in Northern Ireland at Seagate's R&D facility, where they employ a couple of thousand people. One of Seagate's leading R&D facilities globally is in Northern Ireland there, and they're always proud to say that it's one of their most highly innovative and capable centres worldwide. Of course, the other side of it then is helping our entrepreneurs and startups from Northern Ireland to grow out this way. And this is just a selection of some of the local entrepreneurs from Northern Ireland who we're working with very closely here in market. You'll see kind of a lot of these over the next couple of months. We'll have a strong presence at some of the large trade shows like Games Developer Conference here in San Francisco or South by Southwest, where we'll bring large clusters of clients, 10, 15, 20 clients come to market, and we help that as a launch pad for them to try and grow and scale here in the market. So it's not just US companies going in, we also have a really, really strong focus on helping those indigenous companies grow and expand their presence overseas. I'll not delay us anymore. I think we're all probably here to hear from the really innovative guys today, the entrepreneurs themselves. But if there's any questions, please feel free to ask now or pull me aside at the end, and don't be afraid to reach out.
Ryan, thank you. We have time for 1 or 2 questions. Who knows where the Titanic was built? Belfast.
Very good. So yeah, last year was a big year, 100th anniversary of Titanic, and what's really cool is a lot of the Titanic Quarter, TQ as we call it, is now going through one of the largest urban regeneration schemes across Europe. So you might have seen HBO's logo flashed up there somewhere. HBO, I'm sure a lot of you watch Game of Thrones, so that's all shot and filmed in Northern Ireland. In fact, it's shot in what they call the paint halls, which is where they physically used to paint the panels of these large ships that were being manufactured in Northern Ireland. And that whole area, the Northern Ireland Science Park, is there. So a number of these guys that I mentioned, local companies, companies. They're based in the Northern Ireland Science Park, which is in TQ, Titanic Quarter, and we're kind of continuing to see that legacy of innovation continue.
Time for one more question. So I've been to Belfast, Northern Ireland twice in the last 3 years. I've been very impressed by the progress I've seen there, both in the universities and in industry. And today, our speakers here, this partnership with Invest Northern Ireland is in part because of my visits there and seeing what's going on the ground. Northern Ireland there's a lot going on there, and it lends itself, I think, a great deal to what Silicon Valley companies are looking for. So, Brian, thank you very much. So our next speaker is Jim McLaughlin, who's professor in the engineering school at the University of Ulster, but also chief technology officer and co-founder of Intelesens, who's going to talk to us today about connected health research at the University of Ulster. Jim, thank you for coming from Belfast, and tell us what's going on there.
Okay, so Burton, thank you very much indeed for the invite. It's an absolute honour to speak here on behalf of, I think, some of the companies in Northern Ireland and on behalf of my university. First time at Stanford. I've been at Berkeley a few times. Absolutely, what you showed me, I mean, it is inspiring, and I think there's a lot of what you're doing here. Even though it's very different from a typical mechanical engineering school, I think there's a lot that we could maybe learn about. So congratulations on what you've been doing. So I've got 15 minutes here to take you through a story, okay? I think it's interesting, Brian's slide there, the very last one, it's the same slide that I have. I think we sort of go back to this maybe legacy. It's maybe something in our DNA. And I think the shipyard was at the center of a lot of engineering culture. This was a shipyard that employed 30,000 people in the 1920s. Nearly the whole of Belfast was involved in engineering. That DNA just can't disappear. So there is a legacy there in many ways. And you can see, I think, Brian certainly mentioned some of them. I throw up just a couple more here. Air conditioning, the first building, it was developed by Sirocco Works. The air conditioning systems actually fit buildings, and the first one was set up in 1906 at the Royal Victoria Hospital in Belfast. It's a pretty old building, yet the hospital's a brand new building, and they can't knock this corridor down. Still got the air conditioning unit there. And that was the first building to take air conditioning. So many people are very thankful for that. Harry Ferguson and his the tractor that was mentioned, the Massey Ferguson tractor, there was very key engineering developed there to create the tractor. Ernest Walton, originally from Northern Ireland, involved in the splitting of the atom. The injection seat, James Martin. The portable defibrillator, now that's got a story that's very important for what I'm going to talk about just in a few minutes. Discovering the pulsar, Josh and Burnell. Positive and expiratory pressure developed at the Royal Victoria Hospital. And the tank was mentioned, the pneumatic tire was actually first tested about 200 yards from my house in a park, and that was John Dunlop. I mean, the Scottish would argue they own him, but we will argue that he really did the work in Belfast, okay? And there's many others, but that's, I'm just trying to give you a flavour of for a population of 1.7, 1.8 million, it's quite a lot of activity over the last 80, 90 years. So my story starts, I'm director of this centre, the Engineering Research Institute, and NIBEC is one of the main centres within that. The honour of Burton coming over to see us last summer. And I got a bit of a trip around seeing how the emphasis of this is very much on impact into the community, setting up spin-out companies, working with industry, and letting industry, I think, lead a lot of what we do. So a lot of funding, 30 odd million has gone into the funding. Going to focus on it's a multidisciplinary centre, so it's actually was unique. I think there's many centres have been created around this theme, but I'm a physicist, sort of become an engineer, I think. Biologists, electrical engineers, mechanical engineers. There's a wide range of disciplines, and I think if anything, that's probably one of the main reasons this centre has actually been quite innovative. It solves a lot of problems for industry, it creates a lot of new initiatives, and it tries to, with some of these spin-out companies, get in there and be completely disruptive in mainly the healthcare area. Mind you, there's been impact into a range of other companies like Seagate, and Ireland is actually blessed with a lot of your fine American medical device companies, a lot of the manufacturing associated with Medtronic and Boston Scientific and Abbott, etc., Intel and Analog Devices are just examples of some of the very large companies that are based throughout Ireland, and we get a chance to interact with them. So I think this is important when I talk about this term connected health. I don't know if everybody in the room understands what I mean. I'm really sort of suggesting, and it's a big, big word, we're really got this view that very shortly we're going to have to be monitored from home. Very shortly we're going to have a completely remote monitoring system, because the number of people that are living, you know, longer and longer and longer is creating a burden on the health service, and they will not be able to be hospitalized for the times that they're currently hospitalized. So we have to do a lot more to get people at home, or at least be predictive or early warning signs of early stage illness that's appearing, and therefore connected health has the job of doing that via sensors, wireless technology, smart analytics, and there's a whole range of themes that are there. Now, I might argue that we were on the ball pretty early on this. You could take us back to the portable defibrillator. What was that about? That was about taking a large defibrillator and getting it into the ambulance so that it could be taken to the home, and you'd be defibbed at home. That saved many, many lives. That had a huge impact, and that work was originally the concept of a Professor Pantridge from the Royal Victoria Hospital in Belfast, but very much aided by the late Professor John Anderson. John, you can actually see a picture here. This is John, out of my mentor, and over the last 30 years, but very sadly passed away. So John and Professor Pantridge's theme would have been that there's more people that die of heart attacks than of fire, and yet every building has a fire extinguisher, but where are the defibrillators? That was in 1966 that theme was coming out. Nowadays we do see them everywhere. So John started to miniaturize the defibrillator, and you can see the first one with Nybeck building. We have this in view, the little red one, and the one on the left. And in many ways that was all about miniaturizing, getting the product portable and getting it into the home. And that was where connected health started. A huge impact right across the States. I mean, it was actually one of these technologies that was not believed at home. It took John and Pantridge to go to Utah to actually sell the technology at Utah, and there was 2 or 3 major companies in Utah took the concept on, and then John had the chance of developing it back home. So that was 35 years ago. We've since had John and myself working together, had a history of success. I'm not going to go through all these. You'll see the world's biggest selling ECG electrode. We developed a very simple concept around design and the use of less materials, and that for the last 18 years, we had a very strong patent on that, developed by Tyco, but the technology come out of Nybeck. And you can go right round the board there and look at early stage telemedicine that went into Shahal in Israel, and that technology again come out of Nybeck. You can see things like electrodes in wallets, that you pull a wallet out, you hold against your chest, and you look at arrhythmia detection in that. There's enough software in that to actually allow it to pass through a telephone line, and there was eventually some cell net devices in that. I'm not going to go through them all, but you can glance your eye over that, and some of those companies that have taken that work on are actually based here in Seattle, and some in San Francisco. That Verathron have just recently bought this harness technology that you see on the left-hand side. I might say something about that in a minute. My job then back at the university is to create a lot more of this, and I've now been put in charge of the overall connected health, multidisciplinary, multi-faculty, inter-faculty, whatever you want to call it, that brings engineering, computing science, nursing and business, and we'll very shortly bring in our biomedical sciences groups where the biosensing world is brought on board as well. So there's 60 faculty at the minute that are actually involved in that, and if you widen that away out to the student base, you're well over 100, 150 actually looking very strongly at this connected health theme. Now I'm going to rush through just a couple of slides for the interest of time. You're not going to be able to read this, but I want to give you a feel for the wide range of disciplines, that if I can pick out just a couple. There's everything in there from analytics, from ambient assisted living, ubiquitous computing, right into the world of sensors and electrodes to embedded systems, and how micros integrate with wireless based systems, and how micros integrate with the front end sensor. And very specifically in there is getting pure, clean data off the body, processing it and signal processing it with smart analytics so that you save power on the battery, and then you send, usually via Wi-Fi, to the cloud, capture the information, save time for the doctors via smart analytics. So the capability is all here. It's the business models, it's the product design to get that out that's key. The infrastructure is absolutely fantastic, from smart home systems right through to data analytics labs, to patient test laboratories, to clinical trials, to very strong clinical integration to actually pull this through. To quite recently, we put rapid prototyping in the middle of this, and we're trying to build this strength up much stronger. So we design with users, with software developers, we design with telemetry teams, all on one, so that we speed up this process. It took me 11 years to get Intelesens to where it's at the minute. That should be a 1-year process these days, if the systems approach and design approach is right. So these are just some of the themes from ambient assisted living, point-of-care diagnostics, M-health, mobile health that is, personalized medicine. We do a lot of economic assessment of this as well to make sure that we look at the cost benefits, and that's the very important part of the equation for funding, and it's very important to sell back to the health service. There's a range of sensor technologies. Again, for the sake of time, I'm not going to go through these in great detail, but just to highlight, there's some very basic vital signs technologies in there that could still be improved, and we are improving them. Chest worn SpO2 is critical for the development of monitoring of blood oxygen in the body during motion. But we have some very sophisticated techniques in here for looking at an electronic nose for measuring breath, and we're using multivariate analysis techniques here. You can see this little cluster up at the left-hand side to improve data, etc. So there's key illnesses that we're addressing. It might be AF sensing, that's cardiac sensing, sleep apnea. Muse is very important in this area. That's medical early warning systems. Been able to look at a range of sensing systems, put them together in an algorithm, and let a doctor know much, much earlier what's happening. The financial world has used this well. Have they? Yes, they have. And they've used it relatively effectively. So we're taking algorithms from those areas and helping with early warning systems, non-invasive glucose monitoring, novel wearable electrode systems. So we have a few dreams in here. The vital signs area is one, but this will be a very important dream that I have at the minute, looking at blood and doing everything that we've been doing with the ECG world from the point of view of telemetry, and harnessing blood samples and looking at particularly cardiac enzymes where you need to monitor enzyme profiles very fast, using microneedles to stab your skin, take the blood out through capillary without motors, and then broadcast that in real time to match with the vital signs area. Now, just to give you an example, I'm going to give you the story. That's the story at the university and the capability. I mean, it's much larger than that, but that gives you a little bit of an idea of the competency that we have. So Intelesens, just through a slide in here, I know John Hartnett wasn't able to make it today. He heads up the ITLG, the Irish Technology Leadership Group here in San Jose. We won the award in 2011. The company's been going for 10 years. It's got a great board. The actual chairman's from Seattle, Cliff Alferness. Had a big background in medical devices out here, and he loves the company, been part of us really for the last 5 or 6 years. And then the board is a mixture of investors and people with big entrepreneurial experience. In fact, the one at the bottom is Mark Ennis there, the chairman of Invest Northern Ireland. He brings an abundance of expertise. Typically a board's very important. This is the device. You can cast your eye around and see what the guts of the device is. Looks quite simple, but in there's 10 years of very complex miniaturization, very complex delivery of a system that involves digital signal processing to take away a lot of motion artifact. And it's all about really driving sensitivity and specificity and robustness. Doctors do not want false negatives and false positives. The product will not sell. So the software has to look at a range of vital signs, put them together, and give the smartest information it can. So it's gone from what I recall very much a hardware company, which it still is, to big software and very important analytics in there at the minute, and that's very key to what we're actually doing. These are now some of the products. And we've had a very large, one of the big top 5 companies invest in us quite recently. And I can't mention at this stage who, but they're very interested in the respiratory side of these devices, allowing it to be an early warning system. Respiratory is a very interesting vital signs that's been ignored for many years, but put it and link it with heart rate, link it with ECG analysis, and link it with the accelerometer. You're starting to understand then issues associated with sleep apnea, arterial fibrillation, and give you much earlier warning vital signs than are currently available. So that's what the device looks like, and we have very much a home product that's now using Wi-Fi to take the information up to the cloud, and that's some of the design of the new system there called Zensor, and that's been tested in many homes throughout Northern Ireland, and some of the clinical work's also been done out here with Partners Healthcare over in Boston. This is just typically of some of the interesting signals that we've picked up where you would not have expected. The top one is actually people that are suffering AF, and AF is one of the fastest growing illnesses that we have in people over 70. In fact, it's spotted in much younger people these days, and is associated really with the way that we're keeping our body living longer with the likes of stents and improved medication. And with all those improvements, of course, the body has to give in some way, and AF is one indicator where we're starting to see a lot of problems, and it can be corrected with warfarin, etc. The other one at the bottom is an interesting one. This is a guy that was not breathing for about 25 to 30 seconds, and that's sleep apnea.
What does CSR mean?
It's a cardiac illness. It's just arrhythmia. Okay. Now, these are the sort of arrhythmias here that we're picking up. I'm not going to go through them all. There's arterial flutter, arterial fibrillation is mentioned there, 1st degree, 2nd degree, 3rd degree heart block. And then there's a range of illnesses that you see on the right-hand side that we're really tackling with the device. And I say clinicians are coming in and working with us quite strongly in that. So heart sign technologies, I've shown you the vision that John had many years. This is where it's at today. One of the smallest defibs and possibly going to be one of the cheapest as they launch a few new products. This is a portable AED, that's an automatic equipment defibrillator. It has the ability via software to measure impedance and the arrhythmias and automatically shock either remotely or on site. And these are sold all over the world. In the States, very much in Europe. There's actually one in the White House. It saves many lives. They get great reports every day. And this is now quite a large company employing nearly 80 people, value it very strongly at the minute, and is a company probably that will be bought over in the next few years. Hardscape is a company that was recently bought by Verathron that we developed, and this was more in the telemonitoring area and using wearable flexible electrode systems. As I mentioned, the big selling ECG electrode, and this is very much about telemonitoring. You can see a lot of the wearable systems are based on biocompatible inks, polyester substrates to allow them to move and conform with the body. And I think from a design point of view, a lot more can be done to improve areas like this. We're usually constrained by biocompatibility. We're quite constrained with weight issues and regulatory issues in these areas, but I still think this is one area that could be dramatically improved. So I'm coming near the end. I've got 3 or 4 more slides here, and I want to just share with you a couple of important things. What I've talked about is a sensing system taking information. That information goes to a hospital or a clinician to make some emergency decision. But of course, the vision should be that the cloud analytics will make that decision, and therapy, be it defibrillation or be it pacing, or be it a drug itself, is actually pumped into the body. Now, as an example of that, in a heart attack, it is possible to auto-inject TPA, which is an anticoagulant drug that will immediately restart the heart in a lot of cases. So that could be fed via patch electrode systems. So it monitors a VF, and you're sitting there for 5 or 10 minutes with no help, and suddenly, with iontophoresis techniques, you would pump that back through the body. And there's many other examples I could give you in that area. Respiratory is a very fine one. You measure your respiration rate and you do feedbacks and dosages to actually change that. So that's a whole program that we're now working on, that we've got our sensing technology very robust. And to that accord, I've joined a company that again, John Hartnett, you might recognize, has invested in this company as part of ITLG, and they have a base out here. They also won an award in 2010, SISAF. And I'm involved in that from the point of view I'm very interested in following the drug therapy bit, the therapeutic bit. And the interest in this company here, without going into huge details, is the use of nanosilicon and the ability of nanosilicon at critical sizes to work its way and carry a drug into the body through the skin. And with that, it actually then dissolves into salicylic acid. And again, that's compatible with the body, and again, silicon is something that the body sometimes requires. So as we go through toxicity trials in this, everything's very positive to date. But the big issue is that the solubility is improved by up to 40%, meaning that the capability of getting the drug to where you want it has dramatic improvements over current drug delivery techniques. And of course, this is very important for what my vision would be of where connected health would go in the complete feedback loop as regards drug therapy. So to finish, I think the impact of connected health in Northern Ireland has been quite great. There's been a wide range of patents. It certainly went on to saving lives, so it's had that economic benefit. And I think what it's probably led to is a whole ecosystem now that has been created in the country. And I mentioned here the European Connected Health Alliance. It was formed about 3 or 4 years ago, and that's brought 5 countries together. Finland is one of the important members of our alliance. Catalonia, Manchester is a region, Northern Ireland is a region, and Scotland is coming aboard with many others. And it's also brought upwards of about 140, 150 companies together. And we focus some of that into a Northern Ireland ecosystem where about 160, 170 healthcare workers mix with academics and mix with industry to help move this agenda on. It's inspired our 2 very important departments, the Department of Finance, the Department of Enterprise, Trade and Investment, and the Department of Health to come together and form an MOU. One is looking for economic investment, and the other is looking for health benefits. And in the middle of that, there's a chance for innovation to actually grow, and that's what the ecosystem is really trying to address. And I've got some slides in there to show you the success of that. It's inspired some work in America, and in Boston we run a conference every year to show that off. So in summary, my last slide talks about the recipe for connected health device innovation. I think it's important to have good product design from concept to scale up. User needs and cost reduction, the evidence of that's very important, and that's very much driven by regulatory. The flexible business model, the good user-based, the ecosystem that I talked about is clearly important. As miniaturized technology comes along and as robust technology appears, it opens up all sorts of platforms, and we've seen that with the likes of the iPhone. High quality data analytics make a big difference. Early warning with clear patient and clinical benefits is what the doctors need. Smart back-end systems could change a lot of how we go about healthcare in many countries. And most of all, functional and well-designed, intuitive, that meets all the FDA requirements, CE approvals, and easily validated. So that's the design side of it from beginning to end can be absolutely key in this. So again, thank you very much indeed.
Thank you, Jim. Questions for Professor McLaughlin? Yes?
Is the device which you have shown wireless, or is it wired?
Yeah. Well, the devices that I showed come in all sorts of guises, and the user need usually dictates that. Now, there's one system that we're developing at the minute that can only be done via SIM card, so it stores the information, and that's taken away and then processed on a weekly basis. It's got quite a lot of analytics in there to help with that processing. But the majority of systems and the way that we prefer to go at the minute is Wi-Fi. Wi-Fi is a little bit hungry as regards its power consumption, and batteries are not developing at any great rate. So we have design issues when we use Wi-Fi. So to get around that, we try and do as much smart processing on board so that we only communicate during an event. But legally, we have to keep 5 minutes of data stored and 5 minutes of data, 5 minutes before and 5 minutes after data stored, so that we can check out anything post and anything pre. But at the same time, we have to, what's called full disclosure, we have to be able to keep everything on board at the same time. Bluetooth is also a possibility, particularly for some home-based monitoring where Wi-Fi is not available. And we use some MiFi technology to communicate then on out. Okay.
So I visited Jim's laboratory last summer, and I was very impressed because it's one of the few European university laboratories where there's actually a case out front of 4 or 5 different product generations that have been developed over, what, 15, 20 years. This was specifically in the cardiac defibrillation technology. You just don't see prototypes, actual products outside university laboratories at most universities in Europe or here in the United States for that matter. I don't know if you can answer this question, but do you have any sense of what percentage of defibrillators around the world are based on technology out of Northern Ireland today? Is it 20%, 5, 15?
Well, it's a very, very good question, and I don't think anybody has the real figures. I can trace, without going into a detailed answer, I can certainly trace the early developments of the portable defibrillator into a company called Temtech, and then trace that to Marquette. And Marquette were certainly one of the big pioneers in defibrillation, and some of it goes into a handful of other companies in various guises and various ways. So you could trace certainly the whole concept of portable defibrillation into a huge number, huge percentage. Key algorithms are kept very tight and certainly well patented. So it could be argued that each company has its own way of doing things, so they're all slightly different. Hartsign would have a market share at the minute, something in the order of about 7–8%. That figure does differ in a year to year. Global. It does have a big variation on a yearly basis, based on all sorts of things. I mean, there can be recalls, there can be everything from country regulatory issues changing, so that figure can change quite a bit. But certainly, work going on 30, 35, 40 years ago amongst clusters of defib companies had big inspiration on the current defibrillation technology.
I bet you could come up with a number that might be something that Invest Northern Ireland should be thinking about. If you just trace back the intellectual property path to some of the early patents coming out of Northern Ireland, you might be able to come up with an interesting number, and in terms of global impact of early technologies coming out of the Belfast area. Time for one more question. Yes, sir.
Can you talk about the development time of product initiation to actual realization?
Yeah, it's a good question. It's something I from time to time reflect on and wonder why it takes so long. Intelesens as a company has been around for 11, 12 years. Okay. Intelesens, we have a video that I sometimes will show to my colleagues that we took in oh God, whatever it was, 2000, 2001. And we had a system that did ECG respiration rate. Did at 200 meters. It was quite small. So what have we been doing for the last 10 to 10 years? The problem is the market for this, we were possibly very early, and the market pool wasn't fully there. In fact, it was very convoluted. The market pool is getting much, much better, particularly as a good mix of companies know what they want, from the mobile carrier companies to the large medical device companies. And to some extent, these ecosystems are all starting to come through with the one message. And I suppose to answer your question quite clearly, I think it's probably only now in this last year or two has some of the microprocessor and Wi-Fi technology sort of caught up to allow it to be compatible with the type of battery technology that's becoming safe to use and size-wise appropriate to use. So it's a wee bit like, the Apple. I think the timing of that had to be exactly right because of the technology and the user needs and the market demand and all the rest of it. I think this has just come of time now, and probably when we started it 11 years ago, we were starting far, far too early, and the technology just wasn't perfect. We demonstrated these systems. I've got a video, but of course, as the right engineers will ask me, how long did the battery last? And it lasted only an hour, so that's not any good for anybody. It was continuously communicating. There was no smart processing on board. And the only other thing I want to say about it is that we can market this device with the sensitivity and the specificity. That means how sensitive it'll detect VF or AF or first degree heart block. And that's very important to sell it. And the other most important one in there is the number of false positives and false negatives in a day. And that's to do with design and motion artifact and the way it moves around, and also got to do with the quality of the software. And if that is of a 0.5 value, 0.3 value for particular arrhythmias, that will sell well. And the clinicians will buy that instead of what they have currently. So it's key figures that got tested against world-renowned databases. There's the Utah database, the MIT database, the Washington database, the Cleveland database. And as long as you can test well against those databases, that you've got something then you've got something to sell. So that's all that's taking a long time to build that robust type technology, that wearable technology, and to try and do it at a price range that is marketable.
Okay, Jim, thank you very much. So now we're going to shift from Northern Ireland to Finland. Kai is someone I discovered literally just a few days ago. You're based out of Rocket Space, is that correct?
Yes.
Up in San Francisco. And what he's going to do, I hope, is present his vision of computer-aided design and computer-aided engineering and where TinkerCAD has been and where you're planning to go with this. So thank you very much.
Thank you, Burton. So thanks a lot for being able to speak to you guys here. I'm going to start with a quick quiz. How many of you guys are from the mechanical engineering department? Wow, this looks good. How many people know what computer-aided design is? Well, that's pretty much everyone. OK. Thank you. You guys just made my work a lot easier. So I'm going to focus on one interesting question. So TinkerCAD, the company I founded together with Mikko, my co-founder here, is a very, very engineering-driven company. We're trying to solve a problem that's fundamentally a hard engineering problem. By background in software engineering, the company is very software-based, but we find ourselves delving into other supporting areas as we go. The question I want to probe into is, we're currently in San Francisco. The company was originally started in Finland. How did we end up here? What were kind of the decisions of moving out of Finland, moving here to San Francisco, as opposed to continuing with the startup in Finland? So to give you a bit of background of where I come from myself, this is my third company. I've been an entrepreneur in Finland, here, and incidentally actually in Ireland, although not in Northern Ireland, but in the other Ireland, further south in Dublin. I've seen a lot of ecosystems around the world. My wife keeps reminding me that we've done 6 international moves. I lived in a bunch of places, seeing how kind of different ecosystems work or not. I want to touch on briefly what the company does, and then I want to talk about why that type of activity is better suited for the Bay Area, even with the hiring crunch, even with all the kind of certain types of issues that the Bay Area has. Also, I want to talk about why it was actually useful for the company to start out in Finland. So as I said, my own background is engineering. I used to work for Google for a bunch of years. One of the things that software engineers who've been at Google for a while take out from that place is a very different mindset. When you look at a problem, pretty much any problem, before Google you think oh wow, that's a hard problem. After Google you think wow, that's a hard problem. How could I use 500,000 computers to solve it more easily? Eventually they tell you how much that actually costs to run 500,000 computers. It's a big number, mind you, but the cost is actually coming down very quickly. So it's starting to be I think a grad student could probably go with not 500,000, but probably 10,000 cores would be easily within a grad student reach. So that gives you a very different mindset to how to approach things. So TinkerCAD was born from this observation that computer-aided design had seen a plateau in productivity. So initially, when the first digital design systems came out, there's been a lot of research on the productivity increase, and there was an initial 2.5 bump in productivity, basically just by switching to computers. And if you think about it, the manual drawing process of building a drawing, you do one mistake, bang, you're screwed. My father actually studied as an engineer, and he keeps telling me about his heartbreaking moments where he'd been working on some drawing for 2 weeks, and the professor came out for grading or feedback, as it was called, took out the red pen and was yeah, that part's crap, that doesn't work at all, yeah, you need to redo this here. And he's back to the drawing board. He's going to spend 2 more weeks detailing all the stuff. All that disappeared. Over the next 20 years, we had a further improvement of 2 times productivity. So a total of 5 times productivity based on, compared to the manual drafting process, manual drawing process. But the speed of improvement has kind of asymptotically getting close to 0. I mean, every year new software is coming out, and presumably you could say it's better than previously. But in the last 10 years, we haven't seen any major breakthroughs in how you do computer-aided design. Yes, it's better than 10 years ago. There's no question about it. But there hasn't been the type of qualitative changes that those was previously. We founded a company on this premise that there must be such a breakthrough. Like clearly there must be some way of breaking through the mold how we do things, how we have done things previously, and develop some kind of product that actually harnesses this. Not surprisingly, given you have a hammer, everything looks like a nail. A lot of our premise is built on the idea of using large amounts of computing power. Our first project was TinkerCAD. It's a consumer-oriented CAD tool. Most people think it's a browser application. We have numbers assessed that most users, when they hit the front page, it takes them roughly 17 seconds, including reading what the software is kind of about, until they sit in a CAD editor and are doing full solid modeling. What we don't tell you is that this tool actually sits on top of a high-performance computing cluster that's connected to the internet, and obviously every editing operation every solid Boolean operation in the tool is actually powered by a cluster-based geometry kernel. This consumer project has been really successful. It's brought CAD to a very large audience of people who previously hadn't done CAD, mainly because it's a very rugged design. Of those of you guys who've done complex assemblies and so forth, there's often a question of when you get to a full rebuild time, it's very unpredictable when you get a full rebuild how long it's actually going to take if you work like on a 10,000 part assembly or even a large assembly. Because this is parallelized, we can actually most of the time we can actually give it constant response times to pretty much any kind of editing operation you make. What we're trying to do is to take that same idea further. Like the idea of let's say you have 10,000, 100,000 CPU cores. How could you simplify things like, for example, simulation? What if you didn't have like a day-long simulation, hour-long simulation, instead had simulations with like 20 millisecond or 100 millisecond response times. So you could do a flow analysis, CFD, you could do a finite element analysis in real time as you change the model, as opposed to doing the simulation, setting up and going back and forth. I mean, this is a really wasteful way of doing things. Obviously, you're burning a lot of CPU cycles doing stuff, but you're able to compress something like a design phase. You're able to compress human time and instead substitute computing time. And our thesis is this is good. There's a number of added benefits, obviously, because you have a shared resource, a large computing resource. Basically, you can utilize that resource to you can do a peak load where somebody gets the whole cluster to their disposal for like 200 milliseconds, but then somebody else comes in and uses the next 200 milliseconds and so forth. As a side note, there's usually for every single Google query you do, there's actually thousands of computers that contribute some amount of data to that query. So the kind of same of co-tenancy on low latency requests has been done before, but not like at a huge scale. So we're trying to solve an engineering problem that's actually very complicated. I mean, for those of you who know software, trying to do low latency systems is something that's very inherently hard. I used to work with some really brilliant engineers out of Bell Labs, and one of their observations was that throughput is easy. You can just add more stuff. Like you just add more pipes, add more tubes, add more whatever, and more things flow through. Latency, making things fast, is really hard, because you need to take things away. You need to figure out what parts can the system live with. Can the system live with? Like, I can take away that part because that's not critical. Somebody said that you can't make a computer go faster, you can only make it do less work. And it turns out to figure out how to make a computer do less work is really hard. So we founded a company 2 years ago in Helsinki, the town or city capital of Finland where I was born. We ran the company for the first 2 years out of Finland, and we moved to San Francisco. Basically, the whole company moved to San Francisco last fall, so roughly 5-6 months ago. When we started the company, being in Finland was huge. It was really, really good. One of the huge downsides of the valley is the echo chamber. I mean, it's just that you talk to people, you hear people, it's very easy to be sucked into whatever happens to be the really cool thing at the moment. I mean, it's just because there's not too many things there's not too many people around. There's certainly less people than probably there are startup ideas going around. So you kind of end up glomming around those that are kind of the most high potential ones. So the good thing is that you're on top of things. Like if you want to work on stuff that's going to be hot tomorrow, then the Valley is the right place to be. But if you're working in industries like CAD, where things are like not as, how would I say, cutting edge, it might actually be a huge benefit being outside the Valley. Like, I would say that if you have the cutting edge of technology that you see in some places like Google or Facebook or I would say Twitter today or some of the bigger companies like on the software side, Finland is easily a year or two behind. But that's actually good because most CAD companies, if you look at their cloud computing offerings, there's actually a few years behind. Like they're really good. Like there's some really promising offerings out there. But if you just look at the technology stack, it's pretty clear that they're doing stuff that Google did already 4 or 5 years ago. So you're actually not at a handicap when you start out in Finland. Quite the contrary. You have tons of really great engineers. Finland has been the winner in the PISA studies for years. You have all these really hardworking, dedicated people who are like. Here the average lifetime maybe of an employee might be 4 years. In Finland, people work 8 years for a company easily. So if these people who are like super hardworking, really well educated, are not swayed by the latest trend in whatever that trend happens to be, that sounds like a perfect place to start. And it was. We're able to, in the 2 years we stayed in Finland, we're able to build some technology that had been attempted in the past 20 years, but had never actually succeeded. So I talked about the geometry kernel. It's basically the modeling kernel is the part that takes in different pieces of geometry. You could think of it if you have a plate and you want to make a hole in the middle. Somehow the computer needs to figure out what the part, like how the hole is actually going, how the resulting piece is going to look. That's called computational geometry. There's no distributed computational or solid modeling kernel in the world except ours. To give you an idea, our kernel scales to some thousands of processor cores for that single 200 millisecond operation. The most comparable or competing, the best competing library at the moment scales to 4 CPU cores. There's a lot of difference between thousands and 4. And they won't be able to scale beyond 4 because it's an old C++ program written for a single core machine. And actually getting it to 4, like if they try to run it on 5, it doesn't run as fast as on 4. So the technology is just amazing. Like the fact that we'd be able to build something like this, it might have been possible here. We probably wouldn't have had the kind of silence to work on something like that. There would have been too many people telling us that to either work on something else or that it's not possible, that might not be a workable thing. So we're able to take certain risks in Finland, which have been hard to take here. Like they didn't seem like really. They seem like really high risks, a lot of payoff, but in some sense I feel that being in that space, I mean Finland is really, I don't know how many guys have been to Scandinavian winter. I know we have a Swede in the audience. It's let's put it this way, go in July if you have an option. It's literally, I'm not joking, like you have 5 hours of daylight on a good day and stuff. And obviously that doesn't count the cold and everything. So there's plenty of time to stay indoors and code. That silence was important. It enables us to build something, build a part of the culture, part of the engineering culture at our company is basically impossible problems just take a bit longer. And building that type of culture, building that type of kernel was really unique. I'm not sure we could have built it here. I'm not sure we could have attracted that type of, the magnitude of talent we could attract in Finland into the company here. Like, we would have needed to have much more traction to go on. In Finland, we're like, a lot of people who work for us were like, wow, we're like the only interesting option. Like, you can go to Nokia and work there, but you're going to be a big company and do something on the fringes. We're actually working a small startup, a small team, working on something really, really interesting. So that was good. Fast forward a few years, the TinkerCAD project is taking off. We're getting tons of users and so forth. We're starting to collect a lot of data. By the summer of 2012, it started becoming obvious that we needed to move to the Valley. While it hadn't been obvious previously, at that point, our user stats were pretty clear. 85% of our users came from North America. Period. 85. That's a huge number. Even worse, most of the users who wanted to talk to us or who actually were ready to give feedback and sit on the phone came from North America, a lot of them from the West Coast. There was a talk about the 8-hour time difference. I can tell that 10 hours doesn't make things easier. You're roughly like, if you think about it, you're up at 7 in the morning. That means that somebody else is going to be, that's going to be like the end of day for people in Finland. So it's almost impossible to schedule meetings with anybody outside your company if you're 10 hours away. It just doesn't work. I mean, I worked with people in New York, and from here to New York, it feels like it's another side of the I don't know, galaxy. It's crazy. Like it's many hours, like 4 hours to New York, right? Crazy. But 10 hours is a lot more. So I found myself spending a lot of time here. In fact, I found myself racking up a lot of miles, spending a lot of time here. In the end, we decided that technology risk was only part of the risks the company was taking. We're a venture funder like a lot of startups are, and one of our investors through ventures said really nicely. They said that they are super happy taking a lot of product risk, but they also are super happy taking a lot of market risk. And we noticed we were taking a lot of market risk. The problem with market risk is, well, technology risk is easy to take afar. Like if you have good technology and there's a known distribution channel, a known customer segment you're targeting, everything about the market is known, it's really easy to develop that product in isolation. It turns out that cloud-based CAD, this whole idea of revamping CAD, it wasn't clear how you're supposed to do it. We had an idea, we knew we had a vision for a product, but to actually make that product into a useful piece of software for everyone, we needed to be close to the customers. And with me having four, maybe 3 slots, meeting slots, most of them early morning for West Coast people, we're not making a lot of progress with talking to customers. We're not able to actually interview customers. We're not able to go to events where customers were. We weren't able to kind of push that part of the business forward. So in the end, in December 2012, we decided that, okay, I need to move here. And we had a discussion with Mikko, my co-founder, and basically we realized that every time I've been traveling, we had this huge thing of trying to keep up with each other. We literally, we'd sit on Skype every day for 2 hours, and still when we actually were back in the same country again, we're like, oh, where have you been? There's so much to talk about. So it was almost impossible to keep the product development side, which Mikko had, and the customer part, the market side, together, unless we're actually in the same country. And once we figured out he needed to move, there was no idea keeping the rest of the engineering over. So we sat down in August and basically told the company, okay, we're going to move. So you better start talking at home and figure out who's actually going to be with us or not. So I've seen a lot of very, very successful startups in Finland. You guys can have Robbie over here. There's another game company called Supercell, which I know the founders closely. We share an investor with them. And one of their problems is that they're making, I think, on the order of 800,000 USD per day, money. And their main problem is that they have expenses of I don't know, 100K or so. They don't know how to truck the money fast enough to the bank to kind of store it away. But this is a small company, wildly successful. By the way, I don't know these numbers. I read it in a paper. Every time I ask the CEO about this stuff, he just goes So, but in their case, they're developing a game. And they're doing an iPad game or iPhone game to be specific. And then actually, that has a very known distribution channel and customer problem. You basically, if you make it big on the App Store, if you know how to play the App Store, that's it. There's no other question. You just make a really good product, and everything else kind of takes care of itself. Cure for cancer, or some of the stuff that's coming out of Ireland, I think a lot of the life sciences stuff is like this. If you make a device that works, it doesn't matter. You have a certain type of criteria. You can hit those criteria wherever you are in the world. If you hit those criteria, deal done. If it cures cancer, you're done. It's not a question about it. For products that aren't as clear, that don't have external evaluation criteria, I think it's the key. I think you need to be close to your market. It's impossible to iterate fast enough on both the customer side and the product side if you have the teams dispersed. And in the end, we decided that we could have gone with a structure where we had two teams in different time zones, but then you would have all those 10-hour links between the team in the first place, and that didn't sound like any better idea. So in the end, if you're facing both product risk and customer risk, it seems like a very, very sensible thing to be out here as opposed to somewhere else. Well, out here is a bad wording. It seems like a sensible thing to be where your customers are as opposed to where you happen to found a company. It's a subtle difference, but everybody thinks initially they're taking no market risk and they only have product risk. This usually turns out to be false. Pretty much everybody has mostly market risk and almost no product risk. We keep saying we have a lot of product risk. Initially, I thought that meant like 80% of our risk was product risk. I think a lot of product risk nowadays means that we have about 25% product risk, which is compared to the normal like 1 or 2%. So we're like a very product risk heavy company. But most of our risk is still in the customer part, like market part, how the market is actually going to develop, how we're going to find a product that fits the customer profile before we eventually run out of money or scale too fast and so forth. Like all these problems that are familiar to pretty much every startup out there. So that's the story. And that's really all I want to talk about. Like I want to talk about, this is there's a lot of companies with a very like market-oriented thing, but I want to highlight even for a very, very engineering-heavy company, the customer market part actually turns out to be mostly the driving reason for how to relocate or locate your business in the first place. Okay.
Kai, thank you. We're going to bring Jim and Kai up together, but before we do that, any questions for TinkerCAD on what they're doing? Yes, sir.
I have a question whether you're dealing with any sort of distributed rendering in the TinkerCAD product itself.
We don't do distributed rendering per se. The reason we haven't tackled it is that's quite frankly a solved problem. Like distributed rendering is kind of, it was mostly done I think the first real solutions started coming in the 90s. So we're talking distributed as the computer is in one location, but like running over several CPU cores. No, I don't think so we distribute in a sense, we distribute different render operations obviously across the cloud, but that's very easy. We haven't actually gone to the point of tiling up a single render image and distributing that stuff. We might go there, but that turns out to be, from our resource point of view, not a very intensive operation. We spend a significantly amount more resources on the geometry side. Rendering is kind of like I said, it's a solved problem, so we haven't felt the need to and it's not like a resource problem for us quite yet. We'll probably end there eventually, especially once we start like making higher end rendering things. But there's actually a lot of off-the-shelf solutions for that.
It's distributed, but it's not real time.
Say again.
It's distributed, but not real time.
The render we have.
Tie it into the editor where it's real time, that's only problem.
Right. Yeah. Yeah, I mean, most of the thumbnail stuff and the things on the side you could render in a batch-like throughput type of problem. We've been focusing on the low latency, like sub 200 millisecond response time problems.
Other question for Kai? Yes, sir.
How different is this from Sunglass? Are you familiar with it?
Yes, we are. So,
could you repeat the question, please?
Okay, sorry. So the question was, how different is TinkerCAD from Sunglass? Sunglass is primarily a collaboration platform. So what they basically let you do is they let you collaborate around an existing design or like communicate around an existing design, if that's a proper word. The technology we've done, and TinkerCAD in particular, is an editor. So that lets you create new geometry, create a unique geometry, lets you create a custom design. So in Sunglass, it's mostly about talking about an existing design. We actually are, it's not so much a CAD tool as opposed to TinkerCAD, that's actually a CAD tool that lets you edit the design itself.
Yes, sir.
Kai, you mentioned that 85% was America and a very significant amount was here. What do you attribute that to? Is it the maker movement or something else?
Interestingly enough, I love the fact that the maker movement was originally out of Germany in Europe, and then got exported here, like we had New York basically, and then got re-exported back to Europe to a bunch of countries. So. I don't attribute it to actually the maker movement. It might have some bearing on the thing. We saw the same pattern at Google. I think it's just an observation that people here are more willing to experiment with new technologies. And you know, let's put it this way. I see most people in the U.S. Willing to take calculated risks to increase their their benefit for some reason or another, especially in professional circles. Like it's, if you have the ability to improve your work by 20%, but it entails a risk, I think people here are less risk averse than in Europe. In Europe, again, it's like it needs to be proven that it has a 20% increase, and then you go there. So like, the rule of thumb is that mostly there was always a 2-year cycle. So whatever the adoption in the US was, it would take 2 years before the adoption would pick up in Europe. So sorry, the question was actually, what's the reason? What do I think the attributes for why US is picking up so much faster than Europe? I mean, the growth rates are the same, kind of. Like if you look at now we have 2 years of data. Europe kind of looks like US 2 years ago. So.
Let me put a different spin on that. I think Europe has a very broad and deep problem around software, consumer and enterprise. And one of the problems in Europe is that it's, with a few small exceptions, it's simply not an early adopter marketplace. So that's a different way of spinning the risk issue. US companies, culture, for some reason, is much more open to bringing software into existing cultures and enterprises and activities. Europe tends to be very reluctant to do that, either on the consumer side or the enterprise side. So you don't see early adoption out of Europe, and this I think was true for Skype. And what about Spotify? So was Spotify mostly based around the European?
Europe,
okay, so Spotify is an exception.
But the reason
on the
was
they
weren't actually in the States to begin with, so there was no reason to pick it up.
But there's something about Europe's by and large a late adopter market when it comes to software, and the problem for Europe is that if you don't have early adopting customers nearby, it means that most of your startups are going to go to the US, to the early adopter marketplace. And so this is where actually market dynamics have a big impact on job creation. This is where I think there's a huge gap in consumer and management education around the importance of enterprise software. This is where business schools in Europe, in my opinion, are failing tremendously on educating MBA, both undergrad and grad level, business students about the importance of enterprise software and operations, strategy, everything else. It's a very broad, deep problem. And now you're seeing these privacy issues being thrown in on the consumer side around Facebook, Google, other data, which are just putting up additional barriers to early adoption of new software technologies on a pan-European basis. I think overall it sets Europe back many, many years when you don't have early adopters nearby.
Actually, I want to add to that because there's interestingly enough, computer-aided design is there's more CAD users in Europe than in US. And there's also, I mean, Dassault has like over the years done there's been some groundbreaking like innovations in especially bound geometry, computational geometry, also with practical tools like CATIA for ultimate result and so forth. But it's interesting to observe that these have mostly been institutional innovations, either from universities or from big like existing conglomerates and so forth. So there hasn't been a lot of like small company innovation going on. I mean, there's been some really groundbreaking innovation, but it has been in the structure of, again, of the large institution or the large, either the educational institution or the large commercial entity,
so
which is really.
Let's bring Jim up here. I'd like to get a little bit of Finland versus Northern Ireland dynamic, but just one final comment. So this is the second CAD company we presented in the speaker series, the first being GrabCAD out of Estonia last year. What is it about Estonia and Finland that they're developing these new approaches to CAD, new CAD paradigms that, why isn't these companies aren't coming out of the US, out of
That's
Boston
actually very easy.
Or Silicon Valley? I mean, we do CAD, we breathe, live CAD here in the Valley. Why is it that Estonian and Finnish engineers are the ones coming up with these really interesting new ideas and startups? I don't have a clear answer to that. I'm glad you guys are doing it, and that you're coming here, because this is something where we could learn a lot from the Finns and Estonians.
So I'm just going to point out that I know Hardy, the CEO of TinkerCAD. So it's like, I'm going to point out that the Baltic Sea is one of the most kind of poisonous on the country. So maybe it has something to do with drinking the same type of like.
It's the chemicals. It's the mercury. So now, Kai, I know you said you've worked in Ireland. What are your just quick observations about differences between building companies in Ireland, Northern Ireland versus Finland, since you've been in both places?
Right. So I want to qualify. Like again, I was in Republic of Ireland in Dublin, and not so much in Northern Ireland. But I think I think most of it probably holds true. So I think building a company in Ireland and Finland was very similar. Like the ecosystem, the kind of the early type of growth opportunities. I would say to some extent the support from different government agencies, like everything like that, was very similar. I think one big difference was that unlike Finland, where there's 5 million people who speak a language nobody else speaks in the world, and that's not related to any language, by the way, on the planet, Ireland actually has a language which is like mainly understood by a lot of people. My wife picked up this lovely Irish accent while she was there. I sadly didn't. But the observation is there was a lot of US companies in Ireland using Ireland as kind of their base in Europe, because it was, like I said, operations cost was lower, but also the culture was familiar. The kind of way of working, way of living was familiar, and there was like a very highly educated workforce, and it was close enough to all of the rest of Europe, plus it was close enough to actually here. So I think like in terms of country size, it's very similar, same type of enthusiasm and activity, but in terms of the US link, very different. I think Ireland certainly had the leg up on that one.
Yeah, I mean, okay, so in connected health, we've decided very much to reach out and link with Finland, and Finland has decided to link out and reach with us. Irish government in the south and in Northern Ireland have had a view that the countries are very similar, with the same sort of health demographics in many ways, coming out of a time where change has to occur, moving knowledge-based, etc. Put a big emphasis both on the education system, so universities and research centres, and your strategy in Finland is so similar to the strategy that we've come up with, the specialisms that you've decided to focus on. In Northern Ireland we used a thing called Matrix. It's available on the web to look at, and it very much picks on life and health sciences, IT, aspects of energy, and sort of advanced engineering, advanced materials and stuff like that. And when we compared that with the strategy in Finland, there was a lot of similarities. Of course, I mean, the Irish have Scandinavian links, some of us, and probably including my own name, comes from there. So culturally,
was there a time where we came and bashed you guys?
Yeah, you came and bashed us,
right.
and
sorry about that, by the way.
You left your mark somewhere.
My apology.
So this is a formal apology from the Finns.
No, I did.
This is a historic moment here, ladies and gentlemen.
Absolutely.
You're all witness.
I'm a Finnish Swede, so I could probably say for Sweden.
Probably do.
There you go.
So yeah, I mean, I think there's a lot of even socialising and stuff like that. There, we tend to socialise very, very similarly.
Very true.
I mean, in Europe, you have to. It's all about partnerships. I mean, what's known as FP7 that you would know, Burton, and as we move to what's called 2020, our big Horizon 2020, our new vision for funding in Europe. It's all about collaborating countries getting together. So we've got some of the mighty powers in there that will collaborate in their own way with particular themes, maybe around automotive, etc. And some of these, what we would call the maybe North Atlantic Alliance type countries that take in Scandinavia, Ireland playing a role there, UK as well in general, North and South. That sort of brings us together and many playing fields, and then we're able to perform in our own way. You're probably right about the American link, and that goes because of the very strong 40-odd million Americans that have derived from Ireland there. You have that flow coming back. But of course we are within the 8-hour window.
That makes
so we can just about do the conference calls, which means I have very late evenings, dealing with the Californian coastline when we're doing telephone conferencing, and you guys never think of us when we're on the other side. The calls go on to about 8 or 9 at night sometimes, but you guys are just starting your day. But that's, I think, been very, very important. And so medical device companies and then Intel and analog devices are examples of some of the big companies, Seagate that was mentioned earlier. That's actually been driven back into the universities, and there's new initiatives. Actually, the Southern government just announced today new initiatives on industry-led grants. I didn't get a chance to talk about industry-led competence centres that we've developed in Northern Ireland, and that's something that Finland has been very interested in, that idea that maybe some university research could be industry-inspired, industry-led, as well as allowing fundamental work to continue to sustain that. So I think that's where I think we come together very nicely at university, at policy, and the actual makeup of the country itself. So Finland's
So we have time for a couple questions generally on Finland's Northern Ireland, or just general for either of the speakers?
We're happy to talk about other countries.
Connected health.
Represent them badly, might be.
So, I mean, Jim, you were talking about these massive delegations that the Finns would send, totally inundating the local Northern Ireland team. Can you give us a quick, and how many people from Northern Ireland are going to Finland to actually check out what's happening inside Finnish universities and companies?
Okay. So this is all quite new in this last three years. I suppose we've been going over to Boston. That's our main links. Boston, Dublin is very easy to transport on. So with the likes of MIT and Partners Healthcare, we do a lot of work around the Boston area, and we link with companies there. So we formed this thing called NIMAC, which is a Northern Ireland Massachusetts Alliance. Matrez Murray in Massachusetts, she's been very inspirational in healthcare throughout the state, and then I think that's eventually worked its way very strongly into America. So we through what's known as the European Connected Health Alliance, which is based out of Belfast, we reached out to Finland, and I think the Finnish team eventually became known as Team Finland. We're very interested to see how we built up these links with Boston, So when we invited them over, I think initially there was only 10, and there was maybe 20 of us. And then Team Finland arrived over, and there was 50 of them last year, and it was still only 15 of us, so you outwitted us in that. But
I love the pub nights. This resulted in, I say.
So we've been invited back to Finland, and Finland come back to Northern Ireland, and there's always a very large team. Highly government inspired, so sometimes there's ministers coming over, or the head of Department of Health, and we do that with our 2 ministers from Northern Ireland, travel to Boston, travel to Finland to make sure this alliance is politically sound, and it's also industry sound, the sense of industrials are coming through. And I suppose the big question in this big alliance at the minute is who's going to put some funding in to make research projects at the universities work, and then to allow companies to maybe collaborate. And there's early signs of that starting to happen through NIMAC. There's some government agencies, Invest is one, the Finnish government agency as well, and in Boston there's a particular Massachusetts government agency, are starting to put schemes together where funding will come out of that. And that's sort of built on a model I just want to highlight very quickly.
Quickly?
US Ireland funding does exist if you're in the Republic of Ireland, in Northern Ireland, and in an American university. We can collaborate, and there's actually a funding scheme called US Ireland Partnerships. It's 47% hit rates at the minute, and NSF and NIH funding is available out of that.
Kai, I'll give you the last word very quickly, if you have one. If you don't, that's okay.
I'm fine, thank you.
Okay. So I'd like to thank our speakers. Next Monday, Angry Birds and Prezi. So Finland again, and Hungary, top startups out of Central and Nordic Europe. Please join us. Thank you. Please come down and meet the speakers and network. Thank you very much. Have a good evening.